Now, before we just jump into the first classification algorithm, we should be knowing how to evaluate our classification model. That is, how can we make our model better and better? Now, there are plenty of ways to gauge the performance of our classification model, but none have stood the same as like of confusion matrix. So before we jump into the different matrix that we have for classification, let's know about confusion matrix. A confusion matrix is a technique for summarizing the performance of a classification algorithm. So a confusion matrix is an n into n matrix used for evaluating the performance of our classification model, where n is the number of target classes. Again, what are classes? If you could just recall, let's say we are doing binary classification. So binary classification will be having two classes, either true or false, maybe male or female. Okay, male, female, true, false. Okay, so we have two classes. So that will be 2 into 2 confusion matrix. But same thing if, let's say, if we have more than two classes, multi-class classification, we have five classes, maybe uh, to predict out songs of different genre. So one may be pop, one may be classical, one may be lo-fi, so something, all of them. So the same thing we will be having over here. So 5 into 5 matrix we will be having. So a classification matrix is an confusion matrix is an n into n matrix used for evaluating the performance of a classification model, where n is the number of target classes. The matrix compares the actual target values with those predicted by the machine learning model. This gives us an holistic view of how well our model is actually performing. So over here, what we have in this figure right now is an 2 into 2 matrix. Let's rub everything. So we have a 2 into 2 matrix. Okay, 2 into 2 matrix. So this is an binary classification model. This side we have for the predicted value, and this area we have for the actual value, right? So let's look into an example in the next case, where we will be knowing about what exactly is true negative, type 1 error, type 2 error, and also what are true positives. So let's know about what is true positive first. True positive is when the predicted value matches the actual value of us. So whatever we are predicting, and let's say we are predicting if this picture, this shape is a square. Okay, so our model predicts that this shape is a square. So y dash predicts this shape is a square. And when we match it with y, it also says that yes, this is a square. So this case is known as true positives, when our predicted value matches the actual value. Then we have false positive. Okay, so false positive are known as type 1 error. Always remember this. Whenever you go for any interview, people will ask you about confusion matrix, and they will ask you what you mean by type 1 error. So type 1 error is nothing but false positive, when the predicted value was falsely predicted. So let's say, so this is true positive. Okay, similarly we have false positive. For false positive we have type 1 error, and over here for this shape y dash, that is what our model is predicting, is it is a circle, but we have seen that no, it isn't square. So this is an false positive. Okay, similarly we have false negative, and false negative is known as type 2 error. Is in this, just the opposite happens. The predicted value was again falsely predicted. Okay, we predicted negative, but we eventually saw that no, it's a different figure. So that's about false negative. And then we have true negative. So we predict out a value that it is a negative value, or it is a square value, again the same value, and in the actual case also it's a same value. Now, if all of these is not making a sense, let me show you a very famous example that every one of us in the initial stages go through. This pictures is an perfect example of a confusion matrix. What is a type 1 error and what is a type 2 error? So in the first case, we have true positive. Okay. So true positive is if the doctor is telling you you are pregnant and you find out that you are actually pregnant. So the doctor predicts that you are pregnant. Okay, let's say doctor predicts you are pregnant, and after doing the test, it is also found that you are pregnant. So let's denote T by. So both of them are equal, and this is true positive. Now let's jump into false positive or type 1 error. So the doctor says that you are pregnant. Okay, you are pregnant. Okay, but eventually what you find out is the doctor's prediction is wrong. You are not pregnant. Okay, now same thing we have for false negative. In false negative, the doctor says that you are not pregnant. Okay, but eventually you find out that you are pregnant. So that is again the case where we have the type 2 error. Okay, and true negative is, okay, true negative is uh, when the doctor says you are not pregnant and you find out that eventually you are not pregnant. So that is the difference between true positive, false negative, and true no, true negative. The things that you should be remembering out, that true positive and true negative are the ones that we should be primarily focused for the accuracy of the part, because this is the time where our model is working perfectly fine. And type 1 error and type 2 errors are the ones that is something which we should be demonizing upon. Okay, so we should be having least number of false positive and false negative. So that's it for confusion matrix. Let's know about the different matrix that we have in for our classification model in our next video.